Quantum physics is full of strange and counterintuitive phenomena, and over the decades, scientists have designed experiments that seem almost like magic. These experiments challenge our understanding of reality, reveal the weirdness of the quantum world, and push the boundaries of what we thought was possible. In this video, we will explore some of the weirdest quantum experiments ever performed and explain what they teach us about the universe. One of the most famous is the double-slit experiment. In this experiment, particles such as electrons or photons are fired at a barrier with two slits. If observed, the particles behave like tiny bullets, hitting the screen behind the slits in two distinct patterns. But if not observed, they behave like waves, creating an interference pattern as though each particle passes through both slits at once. This experiment shows the fundamental duality of particles and waves and introduces the concept of superposition, where quantum entities exist in multiple states simultaneously. A variation of this is the delayed choice experiment, designed to test whether measurement affects reality retroactively. In this experiment, scientists decide whether to observe a particle only after it has passed through the slits. Astonishingly, the results suggest that whether the particle behaves like a wave or a particle depends on the type of measurement chosen, even if the choice is made after the particle has moved through the apparatus. This raises deep questions about causality and the role of observation in quantum mechanics. Another strange experiment involves quantum entanglement, sometimes called spooky action at a distance. In these experiments, two particles are entangled, and measuring one instantly determines the state of the other, even if they are separated by kilometers. Tests of Bell's inequalities have repeatedly confirmed entanglement, showing that no local hidden variable theory can explain the correlations. Entangled photons have even been transmitted between Earth and satellites, demonstrating that these connections work across vast distances. Then there is the quantum eraser experiment, which builds on the double-slit setup. In this experiment, scientists erase the information about which path a particle took after it has been detected. When this information is erased, the interference pattern reappears, as if the particle knew its path would never be recorded. This experiment highlights the subtle interplay between information, measurement, and reality in the quantum world. A particularly mind-bending experiment involves Schrödinger's cat. While it began as a thought experiment, scientists have created laboratory analogues using atoms or photons. These experiments place particles in superpositions of two states, demonstrating that quantum systems can exist in multiple configurations simultaneously until measured. This illustrates why the transition from the quantum to the classical world, called decoherence, is so important. Another bizarre quantum phenomenon is quantum tunneling, observed in numerous experiments. Particles sometimes pass through barriers that they should not be able to cross according to classical physics. This effect is essential in technologies like semiconductors and nuclear fusion, and it demonstrates that quantum mechanics allows behaviors that defy everyday intuition. The Aharonov-Bohm effect is another strange experiment. It shows that particles can be influenced by electromagnetic potentials even when traveling through regions with no electric or magnetic fields. This experiment reveals that in quantum mechanics, potentials are more fundamental than forces in determining how particles behave. There are also experiments involving macroscopic quantum superpositions, where researchers put larger and larger objects into quantum states. For example, tiny mechanical oscillators and superconducting circuits have been cooled to their quantum ground states and placed in superpositions. These experiments probe the boundary between the quantum and classical worlds, testing how quantum mechanics scales up to larger systems. Some experiments have explored interaction-free measurement, where a particle can be detected without ever interacting with it directly. This uses interference to infer the presence of an object, showing that quantum mechanics allows information to be obtained in ways impossible in classical physics. Finally, quantum experiments are not limited to the laboratory. Scientists have entangled particles across thousands of kilometers using satellites, tested quantum states under extreme conditions, and even simulated quantum systems that mimic aspects of black holes. These experiments push the limits of technology while revealing the profound strangeness of the quantum universe. in simple terms, the weirdest quantum experiments show that the microscopic world does not follow our everyday rules. Particles can be in multiple places at once, influence each other instantly across distances, pass through barriers, and react to measurements in unexpected ways. These experiments challenge our intuition and force us to rethink what reality means at its most fundamental level. The lessons from these experiments are not just philosophical, they have practical applications in quantum computing, communication, sensing, and cryptography. They demonstrate the power and potential of quantum mechanics while also reminding us that nature is far stranger than it appears. Ultimately, the weirdest quantum experiments teach us humility and wonder. They show that even after a century of study, the quantum world continues to surprise, offering insights, technologies, and mysteries that redefine our understanding of the universe.